I never wanted to become a scientist. My dream was to become a mechanical engineer. This is based on a book that I read when I was very young, a book by Jules Verne. And the hero was engineer, and I wanted to be like him. I wanted to be an engineer. And so I went to the Technion, my university, to study mechanical engineering. But fate has its own ways. And when I graduated, the year was 1966. After 4 years of studying, a proud mechanical engineer, a Technion graduate, I could not find a job. No jobs. So I said, well, I need a job and I will do my master's degree, get some salary as an assistant, and in 2 years after my master's degree, I will find a job. So I did my master's, and after 2 years I found a fantastic job, excellent job. But during these 2 years I fell in love with science. And I said, I could be a good scientist, and decided to continue for my PhD. So this was an act of fate. We are all governed by fate, by things that happen to us. We think that we control our lives, but we don't really. Of course, when you walk in the street, you make sure you don't hit other people and you don't go into a tree. When you drive a car, you drive carefully. You control. But the major things in your life, you don't control. I promise you that you will find your wife by chance. So the major events in our life are governed by chance, by things that we don't expect to happen, by a conversation of 10 seconds in the corridor. In my case, changed my life several times. Small talk. Somebody told me something that I didn't know, and whoops, I'm in a different field. Yeah, next.
What advice would you give to students who want to pursue science but are afraid of failure and criticism from others?
Well, this is the job of the parents, to teach the children not to be afraid of criticism of others. Be confident about your capability. But what advice do I give to young people? Okay, let's talk about you. I don't know what you feel. Let's say that you want to be a mathematician professor in a university. And there is a competition. So how to make sure that you win? Well, try to win number one. Now, start trying to be number one in the field that you're interested in. Be it mathematics, biology, physiology, astronomy, whatever you want. But try to be number one in your class, and then in your school. And then develop into a specific field within the area. And if you're number one in any field, you'll have a wonderful career.
How important are quasicrystals in modern science and technology today, and where can their applications be seen in everyday life?
Well, let me divide my answer into two parts. Not every Nobel Prize will have applications. Let me give an example. With me, there were 3 physicists that received the Nobel Prize in 2011. They received the Nobel for discovering that the universe, we knew it was expanding before, but we thought that it will expand and then shrink again. But no, it is expanding in acceleration. That was a discovery. But what can you do with it? Okay, it's not very useful. It's interesting, but not very useful. In my case, there are applications because it's a new set of materials. And when you find a new series of materials, then people start to study their properties. For instance, people that study electronic properties, they will take all the quasi-periodic materials that have been discovered and study their electronic properties. Other people, electrical properties. other people magnetic properties, other people friction and wear, other people mechanical properties, each one in his own field. So because there are so many quasi-periodic material combination alloys, then there are thousands upon thousands of papers, scientific papers, written on their properties. And if a property or a combination of properties is found interesting, then they find uses. The first use was based on the fact that some of these materials are very hard. These are these are intermetallic alloys, metallic alloys or intermetallic. They have very low friction and wear properties, low friction and low wear. So they are like metallic Teflon. So a company in France started to make frying pans coated with quasi-periodic crystal, which is much healthier than Teflon, and they were very good. So this was the first use. Other things, a combination of, if a material is a good electrical conductor, but not very good heat conductor, which is very strange because it depends on electromotion. But if you find these properties, we need it in space, good electrical conductivity, but insulating. So things like this. So these are the practical applications, examples of practical applications.
Thank you.